If you subscribe to the channel, you'll get lots of interesting videos like this one. And if you like the video, it'll really help us out. Please comment down below for any other interesting things. That also really helps us out as well. Hi, welcome to another edition of Easy Theory. So this is another problem set that I want you to work on. So we were talking yesterday about these direct proofs, about how to actually directly prove some assertion. And in this case, the assertion was any rational number, if you multiply it by 2, is also a rational number. So what are some problems that I want you to work on? And to put down into the comments what you think of how to actually prove this, or any insights into the problems that you may have. So one of them is this claim. For every x, every number x that is an integer, so it has to be an integer here. If x is odd, then x squared is odd. So if you have an odd number and you multiply it by itself, then you will get another odd number. But what I'm actually going to do here is actually make this even stronger. I'm going to say, well, x is odd if and only if, with this double arrow, or backwards and forwards arrow, left, right arrow, x is odd if and only if x squared is odd. So that says that if x is even, then x squared is also even. So whether or not this one, x is odd, we can determine what x squared is, either odd or even. It's not the case that x is even, then x squared is odd. So it either stays even or it stays odd. And one recommendation I have in order to prove a if and only if condition, so this thing is an if and only if, is to prove it in both directions. To say, if x is odd, then we try to prove that x squared is odd. And then the other one is, if x is even, then we want to prove that x squared is even. And that would actually prove that this is an if and only if condition here. Okay, so another one that you may want to try is try to show that some statement is actually false. So here's one. So yeah, prove that this is false, which is every rational number, so every number y in Q has what is called a multiplicative inverse. Okay, and what that means is that there is some number, the inverse is some number that you multiply by y to get 1. Okay, so in some sense that there is a reciprocal of that number, of y. So I want you to actually prove that this is false. And remember, in order to prove that something is false, all that you need to do is to find a single counterexample. You can find many if you wanted to, but all you need to do is to show that one example is false. So hopefully that was interesting. Leave your proofs and or other ideas down into the comments. And as always, I'll see you next time.